Okay, now I'm going to show you the function notation. Now I'll just read you this very quickly. The output value depends directly on the input value and the given rule or function. So I'll just give you an example here. See how fx equals to 3x plus 2? This fx is our function notation. Okay, so you'll see that notation very often in this chapter. That's going to be our function notation. So fx, see how x here? That's our input value. That's our input value, and the whole outcome, so fx, which is the outcome after putting your input value in, is our output value. Okay, so that's what it is. So the output value depends on what the input value is, and I'll show you why in a minute. So have a look at this one. Fx equals to 3x plus 2. So here, f0, see how I replaced x with 0? So here as well, x, you put 0 into there. So 3 times 0 plus 2 is simply 2. Okay, so that's all you need to worry about. So for the next one, f1, see how x, I replaced it with 1. So this 1 also becomes 1. So 3 times 1 plus 2 is 5. Okay, and same with negative 4. If I put negative 4 into my x, so that becomes negative 4. It's going to be 3 times negative 4 plus 2, which is negative 10. Okay, so that's the idea, and that's all you need to know. Okay, so this function notation, have a look. And you'll see this very often, so we'll see how we're going to work with that. So question 17 says, if fx equals to x squared minus 3x plus 7, what is f negative 4? So f negative 4, see the input is negative 4. So we've got to change this input x to negative 4. So I'm going to have f negative 4. So all these values of x, I'm going to replace it with negative 4. So it's going to be negative 4 squared. And negative 3 times negative 4 plus 7. And that's what you're going to be simplifying. Well, negative 4 squared is 16. Negative 3 times negative 4 is positive 12. And then we're going to add 7. Just add them all together, you should get 35. That's all you need to do. So it's very, very simple. Okay, so whatever's inside that bracket, that's your input value, just sub it all in. Okay, so 18, gx. So it's not always going to be fx, it could be gx, hx, ix, whatever. Okay, as long as it is in that form, that's going to be our function notation. So here it says gx equals to x squared minus 2x. And this time, they actually tell us that gx is 8. Well, this is gx, guys, right? Because gx equals to this, and it tells us that gx equals to 8. So I'm simply gonna make them equal to each other because they're both gx. So 8 equals to x squared minus 2x. Okay, so I just simply put this 8 into here because that's gx. Okay, and just move it all onto one side. So I have x squared minus 2x minus 8. And that would just be equal to 0, and you can see it's a quadratic, so you can factorize it like that, and you should be very good at factorizing, and therefore x will simply be 4 or negative 2. And we've done a lot of these from our quadratic equations, haven't we? So make sure you know your quadratic equations before you come to this one. That's how you do it. So this was a bit of a different type of question, but you see that you get the idea, right? Question 19. If hx equals to x squared minus 4, we need to find h5. So this time the input changes to 5. So we need to sub in 5 into our x. So h5 is 5 squared minus 4, which is 25 minus 4, which is simply 21. Now b, h2, so into our x we simply sub in 2. So it's going to be 2 squared minus 4. So 2 squared is 4, so 4 minus 4, which is 0. Now c, h root 2, our input is root 2, so into x we simply put root 2. So it's going to be root 2 squared minus 4, which is going to be 2 minus 4, because root 2 squared is 2, isn't it? Root 2 squared is 2, so 2 minus 4 is simply negative 2. Okay, does that make sense, guys? That's all you do. It's very, very simple. Now with question 20, fx is 3x minus 8. It says find the value of x, for which fx is 25. So this time again, like the gx question, where they give us that fx is 25. And we know that this is fx, right? So they're both fx, we can just let them equal to each other. And move your 25 onto the other side, 8 onto the other side. So 25 plus 8, which makes 33, and just simply divide both sides by 3 to get x equals to 11. Okay, so just some algebra there. So it wasn't too bad because it wasn't a quadratic, it was simply a linear equation, so that was very easy. Yeah? 21, fx equals to x squared plus 6, and it says again, find all values for x when fx is 15. So they tell us what fx is, it's 15, and you know that fx is x squared plus 6. So you just let them be equal to each other, like that, and solve again. So I'm going to move 6 onto the other side, so 15 minus 6 becomes 9. So if x squared equals to 9, what's x plus or minus 3? Make sure you don't forget the plus or minus. Okay, so that's the answer for 21. 22. Okay, now this x, now that's a little Greek symbol, so don't worry too much about that. Again, if it has the bracket x, it always represents that function notation. So it tells that it's x minus 3 squared, and it tells us that it's equal to 49. So it's exactly the same as our previous two questions. So you simply let them be equal to each other. Okay? Now x minus 3 squared equals to 49. So x minus 3 is simply plus or minus 7. Right? Don't forget the plus or minus. And then you just move your 3 over and make it plus 3. So positive 7 plus 3 is 10. Negative 7 minus 3 is negative 4. And that's it. That's your answer for x. Okay, so have a look. Question 23. Okay, tx equals to root 3x minus 7, and they also tell you that it's equal to 2 root 5. So again, do the same thing, let them be equal to each other. Now I don't like having surds, so what I'm going to do is square both sides to eliminate those surds. So square both sides, this side will simply become 3x minus 7, because remember the square root and the square cancels each other. So I have 3x minus 7, and here 2 squared is 4, and root 5 squared is just 5. So 4 times 5 is 20, move negative 7 onto the other side, and then divide both sides by 3 to get 9. And that's your answer for x. So it's just solving equations, very, very simple. 24, it says fx equals to 6x minus 2. And it says find an expression for f3a. So the input, see how x is now replaced with 3a. So whatever's inside that bracket, we put it into x, right? So you put 3a into x, just like that. So you have 6 times 3a, because we changed x to 3a, and then subtract 2. So 6 times 3a is 18a, and then subtract 2. That's your answer. So even if the input is not just a number, you can still do the same thing. Now b, f a plus 1. So this time our input changes to a plus 1. So our x is now going to be a plus 1. So for x, you just sub in a plus 1. Okay, like this. So it's going to be 6 times a plus 1 minus 2. And just expand and simplify. So 6a plus 6 minus 2, that's simply 6a plus 4. Do you get the idea, guys? So it's not that bad. Now see, the input is now a on 2, a divided by 2. So x changes to a on 2. This x, change that to a on 2. So it's going to be 6 times a on 2 minus 2. And you can see that 6 divided by 2 is 3. So we have 3a minus 2. Okay, so you leave it like that. That's your simplest expression, isn't it? Can't simplify further. So again, no matter what the input is, just put it in and simplify as much as you can. Okay, 25, fx is x squared, and it says find the simplest form of fx minus f3 over x minus 3. So guys, look at this, fx is just x squared, isn't it? Because fx is x squared, fx is just x squared. Okay, so that's not a big problem. Now what about this one, guys, f3? See how this time the x changes to 3? So what do we do when the input is 3? We simply let the x be 3. So this one will be 3 squared, right? So this is what I'm going to have. It's going to be x squared, because fx is just x squared, minus the 3 squared, because f3 is 3 squared, and the denominator, you just leave it as it is, x minus 3. And then x squared minus 3 squared, we can factorize that, right? Because it's the difference between two squares. So I did x plus 3, x minus 3 on the same denominator, x minus 3, and you can cancel, can't you? So we're just left with x plus 3, and that's your answer. Okay, have a look. So one question can involve more than one function notation. See how it has both? Two different types? But if you just use the same way as we always did with these past few questions, there's not a big problem, it's just a bit of algebra involved. Okay, so that was question 25.